Hello, dear students. Welcome to the third lecture on matter for class 6 ICSC physics. So, in this lecture, the topics I'll be discussing would be interparticle forces of attraction and movement in atoms and molecules. So, let's try to understand what are interparticle forces. So, essentially, these are the forces that hold the tiny particles of matter together. For example, if this is an atom, this is another atom, so there will be a force of attraction between the two. Now, these are the forces of attraction or repulsion that exist between the individual particles of atoms, molecules, and ions that make up a substance. These forces determine how strongly the particles are held together. So, stronger the forces, more strongly the particles will be held together. Now, atoms. In some substances like noble gases, like helium, neon, argon, etc., the particles are individual atoms. So, noble gases are monoatomic, and these atoms experience very weak interparticle forces. Next comes molecules. In many substances, the particles are molecules. So, what are molecules? They are basically a group of atoms bonded together. For example, in water, there are two hydrogen atoms and one oxygen atom. So, these water molecules also experience forces of attractions between each other. Next comes ions. So, there's a class of compound called ionic compounds. For example, salt NaCl is an ionic compound and the particles in NaCl are ions. So, what are ions? They are atoms with an electrical charge. So, now it's like this. So, NaCl is made up of a sodium ion and a chloride ion, and they are oppositely charged. So, they have a force of attraction between each other and it's very strong electrostatic force. So, what is interparticle separation then? So, this refers to the distance between the individual particles of a substance. In solids, the particles are very close together, so the interparticle separation is very small. In liquids, the particles are further apart compared to solids, so the interparticle separation is more than that of solids. Whereas in gases, the particles are very far apart and the interparticle separation is very large. So I have given you three diagrammatic diagrams by looking at which you can understand how the solids, liquids and gases, the particles in solids, liquids and gases are arranged. So next we'll try to understand the relationship between interparticle separation and interparticle forces. So there exists an inverse relationship between the interparticle forces and interparticle separation. So if the interparticle forces go up, the interparticle separation will come down. So when the interparticle forces are strong, the particles are pulled close together, resulting in very small interparticle separation as in the case of solids. Conversely, when the interparticle forces are weak, the particles can move further apart, resulting in large interparticle separation. These two properties are very much linked and they help to explain the different states of matter, and we'll learn this in higher classes. Next, we'll discuss about the motion in particles. So, the atoms and molecules, they are constantly moving. This movement is due to energy which depends on the temperature of the substance. So, higher the temperature, higher is the movement. So, let's try to understand the movements of atoms and molecules in the three states. In solids, the atoms and molecules vibrate in fixed position and they do not move freely. In liquids, the particles move past each other but they stay very close together. Whereas in gases, the molecules move freely and rapidly in all directions. Now, these particles are in continuous random motion as described by kinetic theory of matter, which we'll learn in higher classes, unless they are at a temperature called absolute zero. Very important. So absolute zero is basically 0 Kelvin, which is minus 273.15 degrees centigrade. You have to remember this. And at this temperature, the motion theoretically stops. Why theoretically? Because we cannot attain absolute zero temperature in reality. The movement of atoms and molecules is called Brownian motion, and this Brownian motion refers to the random zigzag movement of the small particles and was discovered by Robert Brown. So thank you. This was the third and last lecture in the series, and if you have understood matter, then please consider subscribing my YouTube channel or liking and following my Facebook page. Thanks a lot. See you in the next chapter.